friends, in our last session we have completed with Otto cycle. In today's session we will study numerical based on Otto cycle. So this is Faizan Kagdi and I welcome you all to our lecture series of basic mechanical engineering. So let's begin with our first question based on this topic. Okay, so the question is displayed on your screen. In an Otto cycle, the compression ratio is 8, which means the value of small r is given, that is ratio of V1 by V2 is given, that is 8. The temperature at the beginning of compression and at the end of heat supply are 310 Kelvin and 1600 Kelvin respectively. Okay, and assuming gamma, that is adiabatic index, equals to 1.4 and CV equals to 0.717 kilojoule per kg Kelvin, determine first how much is the heat supplied and second efficiency of a cycle. Okay, so over here first of all writing down the data. So in the data R is given, so R is equal to 8. Now temperature at the beginning of compression, so you need to see our PV diagram. So observe the process from state 1 to state 2, that is our adiabatic compression process, right? So beginning of compression, which means point number 1, so temperature T1 is given at the beginning of compression, that is 310 Kelvin, and next it is given at the end of heat supply, which means you can clearly see that heat is supplied during a process from state 2 to state 3, right? So end of a heat supply, which means point number 3. So temperature T3 is given, that is 1600 Kelvin. Gamma is given 1.4 and CV is given, that is specific heat capacity at constant volume 0.717 kilojoule per kg Kelvin. You need to determine capital Q and eta. Okay, now how we can proceed? So first of all, writing down a formula for heat supplied, that is QS, which is MCV T3 minus T2. Right, that is heat is supplied at constant volume, so CV, and it is supplied during a process from state 2 to 3, so T3 minus T2. Now observe the equation carefully whether the requirements of formula are satisfied or not. So we would say that mass is going to remain 1 kg throughout this process, whereas CV is given, so M is known, CV is known, even T3 is given in the data, right? But unknown is T2, that is temperature at the end of compression. So how we can determine? So we know that by using our TV relation for adiabatic process, T2 by T1 is equal to V1 by V2 raised to gamma minus 1. But we know that V1 by V2 is our compression ratio, so replacing it by small r, so it is equal to R raised to gamma minus 1. Now from this equation we can determine T2 by making T2 as a subject, so T2 is equal to T1 R raised to gamma minus 1. Now in this equation T1 is known, R is known and gamma is also known. So substituting the value we get T2 is equal to 712.6 Kelvin. Okay, so all the requirements of heat supplied has been fulfilled. Now we can directly substitute in the equation of QS. So we get QS is equal to 636.26 kilojoule per kg. Okay, so the equation is very simple, right? Now next we need to determine efficiency of a cycle. So what is the formula to determine efficiency of an Otto cycle? So we would say eta is equal to 1 minus 1 upon R raised to gamma minus 1. So again a direct application of a formula, and in this equation also all the requirements, that is R is known and gamma is known, so we can directly substitute this value and determine eta, which is coming 56%. Okay, so this is the final answer of efficiency of this cycle. Okay, now let's see our next question, question number 2. So as you can see, the question is displayed on your screen. In air standard Otto cycle, the maximum and minimum temperatures are 1673 Kelvin and 288 Kelvin respectively, which means maximum temperature means, observe carefully PV diagram. So which is a higher point? So we would say point number 3, which means the maximum temperature will be achieved at point 3. So we would say T3 is given, that is 1673 Kelvin. And minimum temperature. So observe carefully. Minimum temperature will be at point number 1, that is inlet to a cylinder, right? That is beginning of a compression stroke. So T1 is equal to 288 Kelvin is given. That is minimum temperature. Now further, it is given that heat supplied per kg of air is 800 kilojoule, which means Qs is given 800 kilojoule per kg. We need to determine first how much is a compression ratio, that is small r, second efficiency of a cycle, and third maximum and minimum pressure ratio. Now over here again maximum pressure, which means at point number 3, that is P3, and minimum pressure, which means point number 1, that is P1. So we need to find out its ratio, that is P3 by P1 is how much, that we need to determine. So it is given that Cv is equal to 0.718 kilojoule per kg Kelvin and gamma is equal to 1.44 air. Okay, so first writing down the data. So as I have written, T3 is equal to 1673 Kelvin, T1 is given, that is written 288 Kelvin, Qs is equal to 800 kilojoule, gamma is equal to 1.4, Cv is equal to 0.718 kilojoule per kg Kelvin. So we need to find out R, eta, and P3 by P1 is how much. So first think about it, how we can determine compression ratio. So we would say that since heat supplied is given, so that is Qs is given, so we know the formula for Qs, which is equal to mCv T3 minus T2, right? Now observe carefully in this equation that which parameters are known and which are unknown. So we would say that Qs is given in the data, Qs is known, mass we are going to take 1 kg, Cv is given, T3 is given, but T2 is not given, which means from this equation we can determine temperature T2. Okay, so substituting all the values, that is 800 is equal to 1 into 0.718 into 1673 minus T2. So making T2 as a subject, we get T2 is equal to 558.8 Kelvin. Okay, so unknown temperature T2 has been determined, but we need to find out R. So how we can do that? So we can see our process from 1 to 2, that is adiabatic compression process. From this process we can say we know TV relation again, right? That is T2 by T1 is equal to V1 by V2 raised to gamma minus 1. But V1 by V2 is a compression ratio, so replacing by R, so R raised to gamma minus 1. So in this equation T2 is known, T1 is known, and gamma is known, so we can determine the unknown R, right? So making R as a subject, we get R is equal to T2 by T1 raised to 1 upon gamma minus 1. Substituting all the values, we get R equals to 5.243, right? So this is our compression ratio, first answer. Now second, we need to determine efficiency. So again, we would say direct application of formula, eta is equal to 1 minus 1 upon R raised to gamma minus 1. Directly we need to substitute a value of R. So we will get efficiency is equal to 48.4571%. Okay, now next target is to determine ratio of maximum to minimum pressure, that is P3 by P1. So how we can obtain this? So what I am going to do in this step, I am going to multiply and divide by P3. So you can see on your screen, I have written P3 by P2 into P2 by P1. Okay, so now further we can determine P3 by P2 separately and similarly P2 by P1 separately. Okay, so how we can find out that? So observe process 2 to 3 carefully. In this process, can we apply our combined gas equation, that is P2V2 by T2 is equal to P3V3 by T3, right? Now from this equation we can say that since a volume is remaining constant, so V2 and V3 are going to get cancelled out, so final equation can be obtained as P2 by T2 is equal to P3 by T3, right? So arranging this term, we can get P3 by P2 is equal to T3 by T2, right? So from this equation we can say that T3 is known and T2 is also known, that we have determined, that is 558.8 Kelvin. So substituting that value, we get P3 by P2 is equal to 2.99391, right? Okay, similarly can we determine P2 by P1? So how we can do that? So we need to observe our process from state 1 to state 2, that is adiabatic process. Okay, so we know PV relation for this process, yes, that is P1 V1 raised to gamma is equal to P2 V2 raised to gamma. By using this equation, can we say that we can make P2 by P1 as a subject? So we get P2 by P1 is equal to V1 by V2 raised to gamma. right? And what is V1 by V2? So it is compression ratio small r. So it is also known. So r raised to gamma. Okay, so directly I am going to substitute this value. So we get P3 by P1 is equal to 30.54. Okay, so this is our final answer of maximum to minimum pressure ratio. Okay guys, so I hope that you are clear with this numericals. So in today's session we are keeping up till here, and we'll continue in our next session with our new cycle, that is diesel cycle. So till then, stay tuned and thank you all.